Hi, and welcome back. So in the previous video, we covered the state machine diagrams. And to summarize, this type of diagrams is in general used to specify the different states of the systems and the actions between them. For each state of the system, we can actually even like show more activities that are going on within that specific state. So that's why we have also the activity diagram. Mainly activity diagrams focus more on the action and activities rather than the state of the system. Okay, state of the system for state like machine diagrams. If we have the activities of your system, the actions, then we are talking about activity diagrams, okay? So how to represent things, we need to be clear because here, like, we need to respect these way of representing things. Okay, it's quite similar, I would say, to the state machine. So we have in the state machine a state represented by this around it, I would say, rectangle. We have the same activities are also presented in the same way, okay? And next we have the control flow, and this is mainly the main reason of using the activity diagram. So is like to show the flow, of the activity, and basically the sequence of the activity also, we can say. So sometimes even you can have some it's not like sequential, you can have some parallel activities that are happening in parallel. So you have one first activity, then here whatever two activities you will have in here, they are running or executing in parallel. So to represent that, we use something like this: one entering a row, and two, or it depends on how many next activities you have. You can have 3, you can have 4, but what we can say is that no matter how much, they are going to be executing in parallel. So in this case, it looks like the fork that we use for eating. So it looks like this, like you have one input, like minimum 2 or plus outputs. So here the idea is that this is called fork, okay? And the fork is used when a control flow has one input and 2 or more outputs, as I'm explaining. Now, the opposite I called of fork is join. Means here we have multiple input or minimum 2, and we are they are done, okay, here. And next, we will join them, or join these control flows together into a single control flow. So there are fork and join. Fork has one input, multiple output. The opposite for join, the join has multiple input and one output. You can also have or see this kind of diamonds with around here. So the first one, if you have one input, one multiple output, so you have something input, then you will decide, I would say, to go with this branch or in this branch. So this is called decision node, okay? So the idea here is that the control flow can go in one or several directions, and you need to decide which direction you will go, okay? So it depends on the condition, and this is why we call it a decision node, because we will decide at this nodes level if we go here or here. Next, now we can have multiple branches that are going to be merged together into one single branch. So in this case, we call it the merge, okay? So you have the decision node and the merge node, okay? You have fork and join, the simple control flow, and the activity. Okay, let's see an example. The example here is of doing laundry. So in this example, what we have? We have the kind of similar, the activity diagram that we are going to do. It's going to be similar to the, let me see, what we seen last time, the state like machine diagram. So we have this activity diagram, and the idea is that now let's go through this. We start we need to sort the clothes in white and darks. So here, if we have white and dark clothes, we can wash them in like at the same time they start. Okay, this is a what kind of node? See, you see this here. You have only one input, multiple output. So we start with the fork. Okay, here you have one input, two outputs, multiple. So this is a fork. These two, wash white and wash dark, are going to run in parallel. Okay, once now, I don't know, maybe they will finish at the same time, or let's say like just I don't make any sense. Whites are going to be washed first and then darks, let's say. So here we need to wait. Both of them are done, then we are going to move. So what type of node we have here? So here we have multiple like output, multiple, sorry, input, one output. So what we have here that has multiple input, one output, this is join, okay? So we start with one fork, then one join. And so the idea after that, once white washed, black or dark washed, you have the dry clothes, okay? So if you have dry clothes here, mainly your diagram is done, okay? So you can see like or like one of the main reason I would say for using activity diagram is actually the ability to execute parallel activities. This is very important. You can even use them within the same state of the system, okay? So then from here probably you are going to be able to call the whole activity. Like here we have the activity we can call do laundry. Okay, so we can call it, and this is going to hide some level of details, and we can even work on it for reusability. Okay, so that is why probably the connection between activity diagram and state machine diagram is that this activity diagram is like to describe how a specific activity inside the state of a system is actually executed. Okay, I wish I made it clear and simple for you, but I want to make sure. So I'm going to give you another example here. So another type, I would say, of activity is like to dry the clothes. So you can run the dryer until, or let's say, if like it's still like wet, you will still continuously keep running the dryer again and again until the clothes are dry. Okay, so after that you can use this like symbol like we discussed here to just like uh, specify, I would say, the here loop. Okay, so here we have one input, two inputs, one output. This is a, come back to the slides, one input from a decision node, one input, multiple outputs. So here is started with a decision node. Okay, so just you need to learn that so you are able to interpret, and if you want to present something, so you can still think of what tools that you can you master and you can use. Okay, so the idea is simple. You are going to use simple symbols in order to present sometimes loops, sometimes like parallel like event like activities happening and so on. Okay, now so let's see like the difference between state machine diagram and the activity diagram. So this like activity diagram are in general used to show the flow of or let's say the flow chart, yeah, of activities that are performed within the specific state of system. So we already are using and kind of activity diagram to actually like move towards all of the requirements specification steps as we said from the beginning of this semester. So the very first activity in general is to put kind of the mission of the object of the project. Then like we are going to try to elicit the requirement elicitation like phase, and we are going to analyze them again and validate them. Finally, what we need is to specify, I would say, all of the requirements in a formal document using visual diagrams. Okay, this what we are doing are visual diagrams that we can use. So we can actually like put the flow chart or like all of these activities and all we learned today together in order to represent an activity diagram. Okay, so I think uh, this is here just the same thing when we want to put like more details about each of these activities. We can do that. Like for the requirement analysis, probably we talked about the different activities of like doing interviews with the customer, like reviewing the requirements, then adding different operations, refining your diagram. So it could be sometimes in loop between you and your customer, and you can specify different conditions. So you can represent all of these activities using like this kind of activity diagrams. Okay, and as I said, they are not about like the state of the system. They are more about the action and the activities that you are running independently from the state. Okay, so let's say or try to summarize things. An activity diagram for requirement elicitation and analysis represents the kind of sequence of activities that are involved in the gathering, analyzing, and documenting requirements for a software project. The diagrams they provide kind of a visual representation of the different stages and steps of the requirement elicitation process, along with the flow of the information. You have also the decision points, okay? And now let's say that the activity diagram, like for what kind of requirement in elicitations we have, I say that we will be free in choosing whatever scenarios we want. We need to identify the stakeholders, even we imagine for a project, for example, is designed for this or that stakeholder. And we need to mainly think about the need of these stakeholders. So this is followed by conducting interviews, surveys, and other data gathering techniques to elicit the requirements, okay? So the diagram may show branches like to indicate that different requirements can be gathered from different stakeholders, and these kind of requirements may have different priorities. So once the requirements are collected, the next step is to analyze them to ensure that they are like kind of complete, they are consistent, and they are feasible. So the activity diagram in this case may show the decision point where the requirements are evaluated, like where like the idea is to include like kind of all stakeholders in the final evaluation or the final list of requirements that it will help us figure out the final list of requirements. Yes. So after analyzing now all the requirements, the next step is to document them. So what you do is it's a clear and like try to do that in kind of concise manner. Okay. So the activity diagram may show a step of for creating requirements document along with feedback loop of if we have kind of review or feedback and we need to keep refining this document again and again. So finally, the activity diagram may show a step for validating the requirements with the final, I would say, stakeholders and getting their sign off. Okay, so this step may include feedback loops for making like changes based on stakeholder input. And again, I would say I will try to summarize more. So the activity diagram for requirements elicitation and analysis provides a high level view of different activities and decision points involved in gathering, analyzing, and gathering and analyzing the requirements of a software project. So it helps to ensure that the requirements are complete, consistent, and especially that they are feasible and that the stakeholders are satisfied with the final requirement document. Okay, so mainly what will have the document at the end, and this will decide about your work. Now, to summarize again, so I think that we are done with the introduction diagram. During the previous lecture, we covered the requirement analysis mainly. We covered different diagrams, and now like we are done with this type of attraction diagrams. So also the class diagram we've seen the sequence diagram, and now the activity and state machine diagrams. So mainly we are doing covering most of these diagrams. Just I want to let you know that probably we'll see other diagrams because they exist, but in this class I am selecting, I would say, the most useful or used, I would say, diagrams that you will see even if you are working and like in the case of working. Okay, so mainly that's it. Now, if you have any questions, just let me know, send me an email, and feel free to send a message or contact me. Okay, thank you so much.